This is Unit 8, Video 2, Solving Linear Trig Equations, and we are going to solve some basic equations using your information that you've got in the past. So the first thing that we're going to do is determine if it's reference angle and then use sine and cosine to the nearest hundredth. So the first thing you have to do is look at this value. You notice that it is 120 degrees. The reference angle is then going to be 180 minus 120, being that it's in quadrant 2. And like I said in the last video, go back and review those rules as much as you have to. It's assumed that we know them here. And we're talking about 60 degrees. So if you need to do the sine of 60, you can get it on your calculator. And the next thing you have to decide is if sine is positive or negative in quadrant 2. This was quadrant 2 answer. You can get the value of the sine of 60 on your calculator if you would like, or you can know the radical. But in this case, we've been asked to round to the nearest hundredth, so calculators are acceptable. Sine is positive in quadrant 2, so this is going to be the positive sine of 60 degrees. And the positive sine of 60 degrees using your calculator is 0.8660. So the nearest hundredth, that is 0.87. And we're also asked to get cosine of 120 degrees. Well, that's the same as the cosine of 60 degrees. And quadrant 2, x is negative, so cosine is negative. So this is going to actually be the negative cosine of 60 degrees. The cosine of 60 degrees is 0.5. And we have to throw the negative sign in front of it. So this is negative 0.5. Looking at the next one, it is 200. First thing you have to do is find the reference angle. So we subtract, this is in quadrant 3. It's more than 180. So we have to take 200 and subtract 180. And we get 20 degrees. The next step is we have to find sine and cosine. So we have to find the sine of 20 degrees, and we are in quadrant 3. So we know that sine of 20 degrees is going to be negative, so we have to include that in our value. And I don't know this one, so we've got to grab our calculator. And I'm already in a menu. I just want to make sure I'm in radians. I changed 2 degrees, just so I don't have to keep inserting the degree symbol. You can do that. Sine of 20 degrees is 0.34202. So that's this one, 0.34202. And I have to remember that I'm in quadrant 3, so it's negative. So I'm going to put in my negative symbol. So this is negative 0.34 to the nearest hundredth. And I've got to do the same thing with cosine. Now I know I'm using the reference angle of 20 degrees. And since I'm using a reference angle of 20 degrees, I need to realize I'm in quadrant 3 and realize that cosine is negative. So I can grab my calculator to the control cosine of 20 degrees. And I get 0.939693. Oh, sorry, 939,693. That's my decimal point. We'll make that my 0, and we will put a negative there since we are negative. And to the nearest hundredth, that's negative 0.94. I will leave you to do this one by yourself. I'm going to pause the video and put the answer up. Okay, you should have gotten negative 0.77 for the sine and 0.64 for cosine. If you didn't, go back and review the procedures before moving on. The next thing we're going to do is actually learn how to solve the trig function in a linear fashion. This is the sine of theta is equal to negative 1/3. And as we used in the law of sines and cosines, we learned how to get theta by itself using the inverse function. So we need to think about the reference angles first and round this to the nearest tenth of a degree. So whenever you do this on the calculator, you ignore the fact that it's negative. You just do the positive on the calculator. So if you see, we're going to do the inverse sine of 1/3. This will always give us a quadrant 1 answer. So our quadrant 1 answer is 19.4712. To the nearest tenth, that is 19.5. So now the next thing you have to ask yourself is, where are the, in what quadrants is the sine function negative? And oops, that's a little bit big. That is going to be in quadrants 3 and 4 based on our previous video and our knowledge that y is negative in quadrants 3 and 4. So then they want us to draw a diagram for the two angles that terminate. So one of them would be over here, and the other would be over here. They have to have a reference angle of 19.5. So the first one goes to this spot right here, and the second one would go all the way to here. That's a funny thing. So now we need to use the idea of reference angles to state the answer to the nearest tenth of a degree using the quadrant rules. So this here, if we're going to do quadrant, the rule for quadrant 3, oh, hold on, try one more time to change the font size. Quadrant 3, rule is that you take your theta is equal to, the angle is minus the reference, minus 180 gives you the reference angle, sorry. So in this case, we're looking for the angle. So we don't know what the angle is. We're going to subtract 180, and we know that we get 19.5. When we solve this, it actually turns out to be 199.5. In quadrant 4, this means that the angle, it is 360 degrees minus your angle gives you your reference angle. So we know that 360 minus our x is going to give us 19.5. Or you can think about this another way and just do 360 minus 19.5. When we do that, we get 340.5 to be our actual angle. So the two answers are, the answers then, again, too large. The two answers are 199.5 degrees and 340.5 degrees. Okay, let's continue on. There are 4 steps in solving these. So let's go over what they are. We use them to answer the last question. Number 1 is to determine the reference angle. So when you do this, you do not use any negatives in your calculator. Number 2, you determine the quadrants in which the terminal rays of the solution lie. You draw a diagram for each solution if it's required or if it helps you. And in 4, you get your answers based off of the reference angle formulas. So I'm going to walk you through letter A. I'm going to have you do B and C by yourself, and then I'll put the answers. I'll pause the video. You pause the video, work them out. We'll put the answers up, and we'll see how you did. So cosine of 2/3. The very first thing that you need to do is that you need to apply the inverse cosine function. So this is inverse cosine. And we're going to do the inverse cosine of both sides, but pretty much you just take the inverse cosine of 2/3. We know that that is going to equal theta. Based off of our conversation in our last unit, we know that if we apply the cosine function with its inverse, we just get theta back out again. So we go to our calculator, we do the inverse cosine of 2/3. We get 48.19 or 1897. And they want this to the nearest tenth of a degree. We now are going to continue on positive. It is positive in quadrants, so it's positive 2/3. Positive in quadrants 1 and 4. So since we're positive in quadrants 1 and 4, we have to use the reference angles. The quadrant 1 answer is just going to be the 48.197, 1897. Rounded to the nearest tenth, it's going to be 48.2. The quadrant 4 answer uses the quadrant 4 reference angle formula, which is 360 minus your angle is going to give you your reference angle. And when you solve for this, it's the same as doing 360 minus the 48. So we could do that over here. 360 minus our answer. Control negative will always take your last answer, and we get 311.81. And we round that to the nearest tenth, we get 311.8. If you would like to draw the rotation, you would have the angles, I'll do it quickly up here. You would have it in quadrant 1, and you would have it down here in quadrant 4. So these are you'd be looking for this angle, and you'd be looking for that angle. Okay, I'm going to pause the video and answer the next 2 questions, and when you're ready, you can unpause and get the. Okay, here's the answer. First you make, let's go to B, first you do the inverse, you get the reference angle is 30 degrees, sine is positive in quadrant 1 and 2. Quadrant 1 gave us 30 degrees, quadrant 2 gave us 180 minus x would give us the 30 degrees, so x had to be 150 degrees. For cosine, remember you don't use the negative, so you do the inverse cosine of 0.47, and you get 61.9657. It's negative in quadrants 2 and 3, so use the reference angle to get quadrant 2. If you had used the negative for some reason, you would have gotten only the quadrant 2 answer, and it would have been more difficult to figure out the quadrant 3 answer. Quadrant 2 answer is 118 degrees. Quadrant 3 answer is 242 degrees. Now the last thing that we have to do is that we have to deal with a linear equation where this is like mx plus b, but the x is hidden inside the sine function like a composition function. So the first thing that you have to do is here is we're going to add 2 to both sides to start to get sine by itself. So we add the 2 to both sides, we get 5 sine alpha, and don't freak out because we're not dealing with theta. We get 5 sine alpha is equal to 2. Then we divide by 5 to get the sine of alpha by itself. After you divide by 5, you get the sine of alpha is equal to 2/5. From here, you use the procedures that we used above. We get the reference angle by using the inverse. So we have to do, the reference angle is going to be the inverse of 2/5. And since it's positive, we are looking for where sine is positive. Sine is positive in quadrants 1 and 2. And we will proceed down that. I'm going to pause the video so I don't run out of time, and I'll post the answers. So if you do this, you get that your alpha is going to be 23.5782. This is your reference angle. In quadrant 1, your reference angle is the angle you're looking for, so it's 23.6. And in quadrant 2, it is 180 minus your reference angle. So, or 180 minus your angle gives you the reference angle, so we get 156.4. I'm going to pause the video and work through this question. You pause too, and then let's check back with each other. Okay, so when you do this, you subtract 1 from both sides. You get 2 cosine alpha equals -1. Divide by 2. So the cosine of alpha is equal to -1/2. When you take the inverse of this, you have to remember that you do the positive, okay? So I left this in here so we could go over that you are not going to put the negative into the calculator, but use the positive. When you do that, you get 60 degrees. But you have to remember you have to think about what quadrant you're negative in, which is 2 and 3. So quadrant 2 is 180 minus x gives me 60. When you solve for x, you get 120 degrees. In quadrant 3, x minus 180 equals 60. When you solve for x, you get 240 degrees. This concludes solving linear trig functions. Our next major topic will be solving quadratic trig functions.